Good evening, good afternoon, maybe good morning in Canada. Okay, let's start. Today I would like to present our research or experiment, or I don't know what exactly is this, but it's a prediction of lithofacies based on the wavelet transformation and machine learning algorithm. This job done with our colleague, with Aman Bekirlan. And a little bit about us intro. Aman Bekirlan is postdoc in university, Nazarbayev University. I'm a PhD student in the International Information Technology University in Kazakhstan. And I have experience in mining, but not in oil and gas, and experience in the uranium mining. And okay, challenge and motivation. When we get information about this competition, we started this competition later, not in the beginning, and we start to think from the business, from the industry, how it's impact or how it's improves their work for the geophysicist or login operator who makes the interpretation. And when we speak with our guys and from the oil and gas industry, they said that if we replace this guy who makes the interpretation in some software or manually or anyway, he said probably it will save 20%. It's time of cost cutting. Okay, it's good. It's quite interesting. Let's make test, play with data. The second part of our challenge is engineering. It's not scientific, but it's engineering. How some supervised machine learning algorithm create the prediction lithofacies based on well log. It's quite interesting. It's not new, but interesting. And for future, it's our maybe future task. It's how we can apply our knowledge from this competition for the oil and gas field. It's not offshore, it's most onshore in Kazakhstan. And the last point, it's my favorite, it just have a fun. It's usually when you participate in the data science competition, you should just have a fun. It's just also maybe for Jeremy about the leaderboard. I think it's not a big issue. Maybe it's just have fun and maybe it's increase your knowledge in this area. Maybe in the oil and gas, in other type of competition. And okay, objective. It's clear for everything, for all presentation what I see. It's to compare the technique machine learning algorithm for lithofacies classification problem. In this competition, we did not apply the technique for the filling missing data. We just get this data and delete. Not all features, but delete. Because we think that it will be generate some biasness in the data set. If you put the median, if you put, for example, some input technique or just interpolation, I think and we think that it will be biasness. And when we speak with guys from the industry, they say, why you have missing data? It's not possible. We pay for the geophysics job. It should be filled. Say like that. And we try to follow this strategy. Also, we don't use the stacking model. The stacking model is good for the competition for data science, but it's not. It's possible, but it's very difficult to deploy in the industry this model. And it's also difficult to explain how this model is works. Sometimes very difficult to explain what is LightGBM or something like random forest. It's quite strange algorithm, random forest. But if you try to understand staking with random forest XGBoost LightGBM, I think it will be crazy. And one point about the John Paul about the feature engineering, it's cluster wells by location. We also look on this part, and when we test, it's not increase our score. It just spoiler for John Paul. Okay. Idea is quite simple. We use the wavelet transformation. From the previous speaker, we see several speakers speak about the use application of the wavelet transformation. We also use it, but idea we taken from this authors from Australia. They use also wavelet transformation to solve a problem of also to boundary of the geology. It's type of also lithofacies classification. They use just only one log. And disadvantages of this algorithm, it's multi-label classification and use just only one logs. And we take this idea, we use the recur wavelet Mexican head and apply it for 1D. From the Lucas presentation, they show also wavelet transformation with log scale and for one log, and we can see there this is wavelet transformation, quite nice pictures. Difficult to explain. Maybe it's easy to apply maybe CNN on this part, but it's I think another story. We use 1D wavelet transformation for one log. For example, for gear, we apply the wavelet and we see what happened. Wavelet transformation almost detect amplitude or a big amplitude or change gradient between the some logs. For example, for RT, we see this is a big amplitude, and wavelet detects this like boundary. And our idea that if we use wavelet, probably we detect some pattern, some part of like this. It will be maybe clay, maybe it will be sandstone, extra. It's just help our model to predict accurate or precise the lithofacies. We apply this for 7 features. It's a type of feature engineering, and our data flow looks like that, but it's like standard already. We have original dataset, generate the new features, split it on the train and test, tuning hyperparameter, training, evaluation. It's easy. And one point, we didn't spend a lot of time for cross-validation because it's time consuming, a lot of data. We didn't have, let's say, resource for calculation this. And we just want to test and to see how it's work. We use tuning parameters based on the Bayesian optimization and normalization standard scalar. It's like this. Also, we know that our organizer provides the matrix penalty matrix, but we also use the Hamming laws, accuracy for Jaccard score for multi-label to see what's the difference. And our results, we make the test on the original train data set. We split it on the train and test. For original data set without wavelet, we have score here. And for the additional wavelet transformation, we get result like that. As we see, we don't see big difference. It's sometimes there, for example, here for the penalty matrix, we see wavelet using wavelet data set features. Our accuracy, our score is decreased. Okay, we say it's alive. We don't improve our score. We should go further. And one point, it's random forest get good result. I know that another guys use XGBoost and show more result. Our expectations that LightGBM should show more higher accuracy, more better score if we compare with another, but random forest show better. Maybe it's due to our train test split. And okay, we use like that and start to understand what random forest show. We use this classification report to show the 12 classes. What we will see, we see that we have problem with coal, it's 10 class, and dolomite for here. It's why we don't have so good result. Maybe first of all, when we try to explain why we have this less score if we compare with another. First, our explanation, it's imbalance. For example, if you see on this distribution, this is part of classes, it's quite enough, but this part, it's very, very small if we compare this. For example, dolomite, it's just only 2,000, but if you look on the sandstone, it's 100,000 rows classes. It's why our explanation, maybe we did not good split the train test dataset. And after our idea, when we speak with our people from the industry, we speak about the random forest, about the matrix, and try to show our results. They say, what is it? I don't understand. And we try to explain him. And probably, you know, this package is quite good and use a lot in the industry also, I saw, and also in the scientific part to explain how your model work and how your model predicts your result. First of all, it's feature importance, and what we will see is that gamma ray impact almost for all classes. Impact with gamma ray, we can, let's say, enough to predict the some classes. If you go to the detail, probably we need another type of logs. For example, I just showed two classes just to compare. For example, sandstone. Usually GR, gamma ray, is in the first and impact more higher on the prediction. If we look on the another class like coal, this is something different. We have the DTAs, Kali, it's very strange, in fact, and pH impact on the prediction of the model for the random forest. And when we speak with our guys from GFE, they said, yes, I use these logs, I use some RGB use, RDP or use. And for another type of classes, another type of lithofacies, they said, yes, sometimes we need another geophysics probe, we need another measurement. And our conclusion, that wavelet transformation will not show our expectation. The score quite similar, not impact, but we believe that such of additional feature could help for another problems in geoscience, maybe for the porosity, maybe permeability need to test. And for SHAP framework, it's good tool to explore and to explain what kind of result you get, to show this result to geophysics, to geologists, etc. And for future work, I didn't see that from previous presentations that speak about the deep learning. I think, and we think that 1D CNN probably will increase score, and maybe in the future we'll make the test. And the next stage, it's apply our knowledge and our experience from this competition to the data from the Kazakhstan field. It's almost onshore, as I already said. And again, thank you very much for organizer. It's quite interesting. It's first time that I see data share for community. And thank you for your attention. I will be happy to answer for your questions.
Thanks a lot, Timur. I really like that shapely explanation of the features. And I can give you a little riddle here. Like, the reason why coal responds very favorable to caliper is that coal is often misinterpreted as coal, because when you have a washout and the density reads too low, and petrophysicists have a bad habit of calling this a coal. In addition to that, coal actually washes out itself quite easily when you drill and the borehole gets slightly enlarged. But I suspect that there's both wrong interpretation and true coal in the mix. And that goes to show some of the challenges that we have with creating a label data set that should not be forgotten here. The label data set also has quite a bit of imperfections. And imperfections is, of course, human. Thank you. Great presentation. Is there any sort of questions to Timur? Timur, sorry. No. So with that, I conclude today. I will split up the presentations and upload them to YouTube. If you want, you could also send me your PowerPoint presentations, and I share them on the Force website for a future repository. I think that could be a nice thing to do. So just put them in a PDF and send them to me. I want to thank everybody. I think it's great that we work as a truly global community on some of these problems, and I'm happy that our data is getting used. There's actually the first publication now out on this Force data, so you have to hurry up to get your names into the scientific journals. And yeah, with that, Peter, maybe you have something more to say here. You're still here. Maybe Peter has left. That's okay. It's getting a bit late here in the afternoon. So thank you very much, everybody. And let's maybe there will be another competition if we find the energy and the money to do so. If you want to sponsor us, you're more than welcome. Okay, bye-bye. Have a good evening.